Hello guys, welcome back to my channel and this is part 2 of this inventory management in e-commerce applications. Just a small request. This is the prerequisite for this part 2 is you have to watch the part 1 video. That is already I have published on YouTube. You just watch the part 1 for this consistency of inventory management in this e-commerce application. In part 1 we have discussed very interesting things. Firstly, we discussed what type of database we can use to avoid high contention. Particularly, there we have seen an example of an iPhone where the quantities were only 10, but the buyers were close to 10,000. So there was very high contention there. So we discussed all the trade-offs, the pros cons of different types of databases, and finally we went with the cache for maintaining the inventory. This cache could be your customized own cache or it could be Redis cache, right? Then finally we discussed when and where the orders should be created. Orders should be created before payment or after payment success. There we have discussed the pros and cons for this both approaches, and we have seen when actually the orders should be created. But after discussing all the trade-offs, all the things, we finally went with the temporary table, that is order staging for maintaining the orders till the payment is done. And what were the benefits for doing that? That purging of those orders would be efficient, because if we maintain these kind of orders also in the actual orders table, that actual order table would grow in size and it would impact the performance. So in this case what we can do is, that is it, we know that this table would be storing the temporary orders for those orders till the payment is in process. Now the purging of these failed orders, let's assume if the payment failed due to any reason, the purging of these orders is efficient. We can do the partition based on date, and the cron job can simply run at the end of the day and can simply delete the partition. So we don't need to delete the row one by one. We can just purge the complete partition in one shot. So it is more efficient. We have discussed all these things. Now let's move for part 2, what all things were pending. So we'll be discussing in this part 2. So firstly, let's see the complete architecture post payment. What would be our steps once the payment is done, right? So this is the complete architecture, the post payment. Usually what happens is payment gateway invokes webhooks once the payment is done, right? That is also we have already discussed, right? In the part 1, payment gateway would invoke the webhooks, and let's assume we have exposed the order service API as a part of webhook to them. So they will call this webhook, and what we will do as a client will create an entry in orders table, right? We'll create an entry of order in the orders table, right? Now because the staging order would be deleted and the actual row would be created in the main orders table, right? Because now the order is no more temporary, because the payment is completed and we are sure that order has to be processed, right? So we create an entry in the orders table. Now what else we do as a part of this? Now there are kind of other services also, or other modules who has to perform some action once the order is placed. For example, the shipping service, for example the analytics service. Analytics service could be like how many orders processed per day. The shipping service has to take some action. They have to they have to pass this order to logistics and all. Similarly, there could be other messages which we need to send. Now let's see what kind of messages we would be publishing to Kafka. That's already we discussed the order update, and particularly order ID, date, status, and the partition key. What we will use is the order ID. That's all right. Now apart from this order update, what all messages we need to send? The other message is the product update. Why this is necessary? This product update is actually the all the product details which are available in the order. For example, in one order, this is the product detail, product ID 1 and quantity 2. This is what the buyer has purchased, right? So what we will do is we will update the product, we will send the product update message. This is a very simple kind of, we will send the product. For example, let's assume there is an order, right? And in this order there are two products, product 1, product 2, and its quantity is 2, its quantity is 10. For example, this is the state of this order. So what we will do is we will send two messages, right? We will send two messages, product ID 1 separate, then product for 2 separate. Now we'll see why we are doing this way, because there are some benefits for this, and the partition key would be the product ID. Products purchased in the order would be sent individually as an individual message partitioned by product ID. Now let's see the benefits for this kind of message, because this is very much important to make the inventory consistent, because this is when we have to reduce the actual inventory, because this is when we are sure the actual inventory is reduced, right? So this is when we need to store this, or we need to update the Redis cache as well. Now let's see what are the advantages by doing this. So let's see why product update needs to be sent separately. Why not a part of order update? There are some benefits for this. First benefit is the performance benefit. For example, here we can easily apply the batching. How? Now product service can easily consume messages in batches. Now, for example, we have already sent partition key by product ID. Now we know in a particular broker, right, product ID 1, that this particular broker would be receiving, and product ID 2, this particular broker is receiving. Now product service can simply consume all these messages in one go, because it is sure, product service is sure that with ID 1 would be sent on the same broker, right? Now product service can easily consume the messages in batches. For example, 20 to 30 messages. This also can be configured, group by product ID, and can simply update the count. For example, there are 10 messages for the product ID, right? Product ID 1, quantity 2. Similarly, there is one more message, product ID 1, quantity 3. This message could be part of order 1, this message could be part of order 2. We are not worried, because we are sending the product messages separately. Now what we will do, product service will club all these messages, product ID 1, and total count, what it is, total count is 2 plus 3, it would be 5. So the product service can easily batch all those messages and can update the count directly in Redis, and also in the main products table in the actual database. So it is lightning fast. Just we are not doing the count minus minus anymore. We are just doing the count minus count equal to count minus n. So this is the benefit which we are getting from this approach. So that is why we are choosing this way. And finally, we will commit to Kafka. This is very fast. This is how we will make the inventory consistent on payment success. Now we have discussed this thing as well. Now let's discuss the order timeout. The remaining thing, the last pending thing is the order timeout. What would happen if the payment not completed in a configured time, right? Now when the payment is in process, we already made the entry in order staging table, that we already discussed, right? For example, this is the order timeout update message. Now let me explain that this is the order service. As soon as we'll make the entry in this temporary table, we'll send a particular job schedule kind of message in this Kafka as well, right? Now there are worker threads, background worker threads, whose job is to update the inventory in Redis cache only, right, in Redis cache only, because we don't need to update in the main DB, because this is just a temporary order which has been failed due to timeout, or due to payment not failed, or due to any XYZ reason. Right now, these background workers could be in product service or could be a part of separate service. These background workers can directly update the Redis, right, with the very simple operation. For example, the decrement by operation, and or decrement operation, that is the particular key which we have already discussed, 1 minus reserved inventory, right, and decrement by n. For example, in this particular order, the product ID 1, right, and its quantity is reduced, these three quantities were there, for example, right. So what would happen here is simply decrement by, this is the key which we have already discussed in the part 1. This is the product ID with the combination of this reserved inventory. We discussed all this in part 1. So we'll simply apply the decrement by function, and we'll directly decremented all the count of these products who are failed in this order by just one operation. That is also very fast, and we have done this operation atomically. Now this is that simple. If the order status does not change to confirmed, reserved inventory would be reduced, right. This is what we have done here. The order timeout update message, what when it would be sent, as and when the orders uh, entry is created in the order staging table. When this entry would be created in this table, on the at the checkout click button, when user clicks on checkout, this entry would be created, and this also message would be sent. The background workers would see the time for this, and would see the configure time, for example this time, and the configure time, payment configure time, payment timeout configure time, right, payment timeout configure time. If this timeout time is greater than this particular date, then the background workers would execute this particular job and would mark the order, would decrement the inventory of that particular product. So that is how we would make the order timeout as well, till the payment is not till the payment is in till the payment is in process. So but still, there are few edge cases. Let's assume if payment response webhooks not received in a certain period. Let's assume there is a latency at the payment application, right, and we did not receive the webhook message. No, what would happen? Our background workers are still in action. They would keep running, and they would keep checking that particular time, the payout configure time minus the order place time. So they would keep checking that, right. If that time interval is greater than the, for example, the payout configure time, then those workers would decrement the product inventory count, right. That's what all we discuss. Now that is what, when the payment gateway actually invokes the webhook, right. So at this point of time, the order service would send in the response that the order is already timeout, the order is already timeout. That is when you see sometime the messages on mobile that payment deducted, then suddenly you see the payment credited as well immediately, and sometimes you see the message payment deducted, amount would be refunded in some time, right. So that's how your orders, inventory, and payment services doing action behind the scenes. And you can see the inventory data is so much critical, right, for users, right. So that's all for this video. So thanks for watching this video. So if you really like my explanation, please do watch other videos, and subscribe my channel. We'll see you in next video. Thanks a lot. Thanks.